log, so basically we have to understand what is the log. If we know anything as the exponential form is like, just suppose, for example, I said 2 to the power 2. Is it like 4? Means this term, this equation is a form of exponential term. Anything is written in the terms of power becomes the exponential term, and in this exponent part, this is known as the base digit. This is known as the power digit, and this is the value of that. If I want to write the same thing, the same exponential in the term of log, so I will write the same thing as what? Log. And always this base value comes in the base of log 2 here, and it is written with the value 4, which is equivalent to the power will be the answer here too. So you understand what you have written? For example, for another example, if I say if anything is written as 10 raised to the power 3, which is 1000, then this is exponential part. Here, this 10 became the base, the 3 became as the power value, and 1000 is the value of 10 cube. If I want to write this in the term of log, then log will be what? Log 1000, and base is 10 here, which has the value of 3. So this base has a very important role while solving the log, because base plays a lot of role with that. If we are using different base, then the values are different. You can see if I just written this as what? 2 to the power 3, then this becomes something value near about 8. So if I write this as log base 2, which is 8 here, this will be 3. So base plays a lot of role while solving the log. We have to be very careful about that. Most of the time for Acer, or you can say for GAMSET, they use either log, either ln. So what is the log and what is the ln? A difference between them is that what? Ln means instead of base, we use e term. Instead of base, we use e term, but in the log, if they have written log and they have not defined any kind of base value there, then we always suppose it as base 10, because base 10 is considered as the common log, and the base e or ln is considered as the natural log. This is as a part of natural log, and this is a part of common log. Both are always different. If we have to solve the terms with the base, then the base values are different. For example, if I want to show you how they are different, then you can see, as I said, log base 10 here, this will be, if it is a suppose 100 here, then you got the value of this is something around 2. It means if the exponent part of this is like what? 10 raised to the power 2 is equivalent to 100. But if it is written as a form of what? Log base e100, which is like, just suppose if no value is given here, then what it's mean? It's mean this is, and in the part of exponent term, this is, suppose if we have write x here. So this is written as e to the power x is equivalent to 100. And now what will be the value of x? This is something like this, and this is something like this. So both are different. Log base 10 and log base e, both are different. If I say we want to convert the log base e into log base 10, so that we can calculate the problem easily. So for this idea, what we do, if we want to convert log base e, it means ln, simply it means ln into log base 10. So what we have to do, we have to just multiply it by what? 2.303 value. We have to multiply it by just 2.303 value with the log 10, and now this log e will be changed into the log 10 base. If any value is written here, then that value remain unchanged. Just suppose 4 is written here, so 4 will be also here. No change with that. So by using this approximation, if I say log base 10 and 1000 here, this was the 3. So similarly, if I ask what will be the value of log 1000 base e? So do you guys any idea how we can calculate the value of this? We can easily convert this as by multiplying 2.303, and now I can write this as log base 10 times 1000, and this value is just 3, so I can say this is 2.303 times 3, and now you can easily multiply and you have the answer for log base e 1000, which is something around 6.909. So there is a huge difference between the log 10 value, log base 10 value, and log base e value. Be very careful about that while solving the problems of Acer or CAMSET as well. Now, there is some more formulas, algebraic terms related with the log. I want to discuss that as well. But before that, I want to say one more thing here. If the log term and base have same values, then its value is always 1. For example, if I have written this as what? Log base 10, and 10 is also here. The log term is also 10 here. So what will be the value of it? It will be 1 because the base are same. If it is written as what? Log base e, and e is also here, then I will say this is also 1. Even any base, if the base and term are same, log base e and just log base 2, and suppose 2 is also here, I will say this is also 1. If it is log base 3 and 3 is here, I will say this is also 1. So now I think so you have a very clear idea about the base. What is the difference in the base 10? What is the difference between log e? If they are using ln, I want to repeat this. If they are using ln, it means the natural log, which is log base e always. I want to say the log base e, if you want to calculate the value of log base e in terms of 10, then this is always 2.303. Now, let's come to other formulas associated with the log. So if I talk about more formulas, more algebraic ideas of the log, then you can say the first term is what? If anything is written as log, any base value here, I can say any base value e 10 2. So I'm just supposing a. And this is, there is two terms as mn. So I can write this as log base same m plus log n. Any base can be possible here. The second term, if I define it here, then you can say this will be log any base value. If these terms are written as m over n, so this will be like what? Log base a, this will be m minus log base a n. So if you have anything as like log 2x, then you can write this as log 2 plus log x. If you have anything as like log 2 over x, then you can write this as log 2 minus log x. Now, the third term we have as what? The third term we have like if log base a m to the power n term. Means if anything is in the form of power, then I can say this can be written as n log base value same and m here. So these are the three major formulas which is always useful and helpful to solve the question based on the law. If I just see a problem on the basis of the same situation, like we have to solve a log value, then I want to say, can you please calculate what will be the value of log 2 times 10 raised to the power 6? And I want to say the base value is 10 here. It is also given log base 10 2 is something around 0.3 value, or you can say 0.30 value, and log base 10, and 10 is also here. Can you please tell, like any one of you can tell me the value of log 10 base 10 value? Hey guys, any one of you can tell me this value?
Sorry, did you mean the log base 10? That's
Yeah,
one?
of course. Yeah, that's 1. Why it is 1?
They cancel each other out.
Don't say cancel each other, because I have said that if the base and term are same, then the value of that is always 1. I have clearly written that earlier here, if you can see that, right? So on the basis of this approximation and using the formula, can you please calculate the value of this? So if you just look at this idea, then I can break these two terms as log m times n term. So what will be the formula for log m times n term? Then I can say this will be log m plus log n type term. So this is log base 10 and this is 10 raised to the power 6. Now you can see the log 2 value is clearly defined here, which is 0.30, but the value of log 10 raised to the power 6 is not clearly given. So I can apply the second formula here as the formula log m to the power n, which says it is n log m. So I can write this as log 2 base 10 value plus this can be written as 6 times of log 10 and the base 10 value here. The value of log 10 base 10 is just 1 because the base and term are same, and here the value of log 2 is just 0.30. So this becomes 0.30 plus 6 times 1. You can say this will be 6.30, which will be the value of log 2 times 10 raised to the power 6, or you can say log 2 million with base 10. Hopefully you got it this. Sometimes if I ask a relation of the log term with the another term, for example, I have this question here. I want to just pick this formula. No need of reading the passage right now. We have to solve a question based on this idea. So I read the passage next time. Just look at this formula, and you have to form a relation between log xt with the t. You can say xt is just defining here the concentration of that reactant or that something, you can say any element at time t. So we have to form a relation or between the log xt with the t. So any one of you are able to see this or understand what I mean? So they are saying like log x naught over xt is equivalent to kt. We have to form the relation between what? We have to form relation this xt and this t. So can anyone tell me which approximation I have to apply here first, just to see the relation? What is the relation between them? Any one of you guys? Drisha, would you like to tell this?
Do you just minus it, ln log in the x naught minus the ln?
Perfect
x.
idea. We can apply this approximation log x naught minus
Yeah.
log xt is equivalent to kt.
Yeah.
Perfect. Now, can I say if I have to see the relation of this and this term, then I can suppose the other parameter as a constant parameter. Means I will suppose that k and the log x naught are a constant value which are not changing. So this will be log x naught minus of ln xt is equivalent to kt. If I suppose this term and this terms are constant, then this become minus of ln xt is directly proportional to t, or we can say ln xt is directly proportional to minus of t. So this is the relation between the ln xt, or you can say the relation between the ln xt with the t. So we got a relation which is directly proportional with the negative sign. Hope you understand what it's mean. Now, if I talk about some question on the basis of log, how they ask the question on the basis of this. So I want to say at the Acer set. If any one of you joined the last seminar, which we have done on the sound, then I discuss a question on the basis of sound. where we are working with the sound intensity level. So we use the log approximation idea there. I think I have not explained too much there, so that's why I just explained the log system. So we have this question on the basis of log, and they ask something here. I want to just discuss the question number 110 here right now. I will discuss all of them later. So what about the question 1110 if they have given this passage here? So they have given something here and they want to know the some value of it. Hopefully it is still visible for you. It's not too much small sentences. So they have given two design of hearing at S and T are being evaluated. The figure shows the amplification here. So this figure is given which shows the amplification between the two ads which we can hear very clearly. Now they have defined some kind of graph associated with that, and then they have described in the passage as like the curve for T, the curve for S, just is shown by dashed lines with the frequency less than 1200 hertz. Hearing at as the was tested as the input of the range 70 to 80 decibel, and the T was tested as something around 90 decibel. Now they want to know both hearing aids are designed to amplify the frequencies of normal human speech. So they have given the frequency range as 1000 to 500. Now they have defined a formula here which says dB. dB is like, you can say, sound intensity level is like 10 log base 10 I over I naught. So they are also described where I is the intensity in, actually they have given this is as unit here, which shows that this is watt per meter square. And the value of I naught, which is known as the, you can say, a constant value of the intensity, which we can hear easily, that is 10 to the power minus of 12 watt per meter square. So on the basis of this idea, if you just look at the question number 110, then they want to know what will be the closest factor by which hearing and S multiplies the intensity of 1000 hertz sound. So they have given the intensity of sound, which is 1000. And they want to know, this is the given intensity of the sound, and they want to know here which factor by hearing add S multiplies the intensity of sound 1000 hertz. So mostly they want to know something around what will be the factor if we calculate the add S at 1000 hertz. So if we have these relations, and we have to find out, let's calculate the value of dB here first by using the value of I and I naught. So how can we calculate that? Let's continue. The dB is like 10 log 10 I means the intensity of 1000 hertz. 1000 hertz is like the frequency here. 1000 hertz of sound is like a frequency here. We want to see what will be the intensity of S at this frequency range. So if you just look here, then at this 1000 frequency, the value of S is something around 15 decibel. This is the dB. Here we have to find out the value of I. What is the value of I? Because the decibel, the sound intensity level is given, which is something around 15 decibel. The value of I naught is also given, which you can see here, which is 10 to the power minus of 12 watt per meter square. And the value of I we need to calculate. So how we will try solve it? So we will apply the given formula and the log expressions, and then after we will apply the conditions for the log. So first term, this is given as decibel dB is equivalent to 10 log base 10 I over I naught here. Look, dB is given as 15, which is like 10, and this is like log base 10 I value we need to calculate, and I naught is given as something around 10 raised to the power minus of 12. So this will be 15 divided by 10 is equal like log, this became 10 I over 10 minus raised to the power 12. Now, for this term, for the second term, I can apply the approximation of log m over n. So I can write this as 1.5 is equivalent to log base 10 I minus log base 10, and this is 10 raised to the power minus of 12 as 10 raised to the power minus of 12, which will be the base 10 value here. So first approximation I have used here as log m over n as log m minus log n. And now I'm going to use log m to the power n as my n log n. So if I apply this approximation, then I got 1.5 is equivalent to log I. Sorry. Minus, you can look minus 12 as a power of 10 means it will become first. So minus of 12 here, and this will be log 10 and 10. Now you know that the values for base is always same. Like if the value of base and the term is same, then its value will be 1. So this became log I, and this became plus 12 value here, and this is like 1.5 here. Let's see, are they defining any value here for the log term? So no, they are not defining any value for the log term here. Now we found that what this will be 1.5 minus of 12, which is log I. So the value is 1.5 minus of 12. Wait a second. I think they want to know the factors. So wait a second. I think we not need to do this idea here. Actually, they want to know the factor means they want to know the value of I over I naught. That's it. So don't put the value of I naught. That's fine. So this will be 1.5 is equivalent to log 10 I over I naught here. They want to know the factor. That's why we are not putting the value of I naught here. Now 1.5 is like 1.5. We have to solve it. What will be the value of 1.5 in the term of log? So 1.5, can I write this as 1.5 times 1, which is log 10 I over I naught. Now log like 1 can be written as, you know, like 1 can be written as log 10 as well. Log 10 base 10 can be written as 1 as well. So I will apply this idea here, and I can write 1.5 times log base 10 and 10 here, which is log base 10 I over I naught. Why I'm doing this approximation, why I'm making 1 as log 10, because I want to cancel out the term of log for both sides so that I can get the answer easily. Now it will be, can I say 1.5 will be in the term of power here. So this will be like log, I'm just using this approximation, this second approximation, but in opposite manner. Now I have n log m. I want to convert this as log m to the power of n. So log m to the power of n. So log 10 to the power of 1.5 base 10 here, which will be log 10 I over I naught. So now if you have any case like this, then you can comprise the values of log on both sides, like the value of log of left side as the value of log of right side. So the value of log on left is 10 raised to the power 1.5 is equivalent to the value of log of right is I over I naught. So I over I naught became the factor for that, which has the value of 10 raised to the power 1.5. If we talk about 10 raised to the power 1.5, then it is like, you know, the square of 10 is something around 100. So how to calculate the value of 10 raised to the power 5? If you calculate that, then you will got, this is something around 31. So 31 is like factor for I over I naught. So the best answer should be D here, 30, which will be the factor of hearing the add S. So this is the idea for the log which we used here to solve the conditions for all of these things. Now, if you guys have any doubt, you can ask. If no one has any doubt, then I can proceed for the next. Anyone has any doubt? Okay. So we are again back on our log page. And now we have saw the how to form the relation, how to solve the questions associated with the log. So now we know that I can write 1 as log 10 or 10. Even I can write 1 as log base E and E as well. It's on us, it's on our requirement which we use depending on the condition, depending on the situation. If the calculation says you have to form the terms as natural log, then you can form it as natural log, otherwise as common log, then you can form it as a common log. Now, we also see the condition log E or ln E, ln as like 2.303 log 10. So this is log here and it means log base E here. I want to give you some more tricks about it. If any terms are in the form of common logs, common log means what? The log base 10, the log with the base 10. So if anything is like this, always remember 10, and if 2 zeros here, then the number of zeros, its value always. So if we are talking about the common log 100, it means the value of it is 2 because there is 2 0. If I say log 1000 and the base is 10, always remember base is required. If base is 10, then the value of 1000 is like 3. If the log 10 raised to the power 6, then always remember the power will be the answer for it. So 6 here. If I use approximation log 10 raised to the power 10, 12, so it will be 12. Now you can use this both terms vice versa. Even you can write 2 as log base 10 100. Even you can write 6 as log 10 raised to the power 6 base 10. So use according to our suitability, use according to our requirements. So these was the all the conditions related with the logs. Now let's discuss about some properties associated with the graph, and then after we will solve some more question on the basis of log ideas and some other factors as well. Log is also more important in the chemistry. So let's try one more calculation based on the log idea. I think one more will be good for the basis of log. So just suppose if the terms are given as log 2 over x plus log x square, which is equivalent to log 3, and then they says find out the value of log, find the value of x, find the x. So I want to give you just a 2-minute time to solve it. If you want to solve, then solve it, otherwise I will proceed. And also let me know if any one of you solving, otherwise I can proceed. Subham, would you like to solve this?
Yeah, I'm just solving this one right now.
Okay. Here, Meena, you can also try. Drishya, try this. Supriya, Patricia, Zoita, Amin, Ellen, try. Okay, so first of all, it seems like this is written as log m plus log n term. Means we know that log m times n is always log m plus log n term. So I can, if the terms are given like this, I can make them like this as well. So I can write this as log 2 over x times x square as well. And the second term is log 3. Now, as I said you, if the terms are like the left side and the right side logs, and you can see now we can easily equate their values. So we can say 2 over x times x square is just like 3. What we did, we just compared the values of log. We just compared the terms of log. Also, be very careful about comparing. The base are same on both sides. That's why we compare. If the base are not same, then you know that you have to first convert the base into the same basis values, and then after you can proceed. Now, can I say this is like 2 over x times x times x? So 1x will be cancelled out here, and this becomes 2x is equivalent to 3. So x is like 3 over 2. Or you can say x is like 1.5. So just by using the formula, just by the good understanding of the formula, you can clearly solve, you can easily solve the values of log. Even you can find the value of anything with by using the log x. Sometimes they give the terms as exponent form or the log form. Just suppose if they have given as what log base 3, and this is x here, which is equivalent to 4. And this is find the value of x. This is find the x. This approximation is mostly useful in chemistry while finding the pH value. So calculate the value of x. So for this, I will definitely say, don't forget that idea when we converted the exponent into the log. So our exponent term was like what? If y is like a to the power x, then how we written this? We write this as what? Log. This a is like in the base y here, which is equivalent to x. I want to use the another idea here. Suppose b here. Suppose like b here. So now the term is given like this. I want to convert this term as like this. So base is always like base value, means 3 is always like base value, and 3 to the power 4, because b is like, if I just comprise this term with this, then I will got like b is like 4, y is like x, and a is like 3. So I can write this as what? Y means x is like what? 3 to the power 4, and you can easily make as like what? 3 to the power 4 as 3 times 3 times 3 times 3, which is something around 81. So we easily calculated the value of x as 80. Now I want you guys to solve just one value. If I say calculate the value of log 32, if this is written as base 2, you have 1 minute to solve this. Any one of you just give the answer for this. Log 32 and the base value is 2 here. Hey, any one of you calculated?
Is the x 4?
X. So I'm just asking the value of it. No x here, okay?
Oh, sorry. Never mind, 1 second.
4 or 5. Armin said 4 or
5, I think.
Of course it is 5, because 2 to the power 5 is 32, right?
Yeah.
So 2 times 2 times 2 times 2 times 2 is always, you know that 2 to the power 3. 2 square of 2 is like 4, square of cube of 2 is like 8, then 2 to the power 4 is like 16, and then 2 to the power 5 is like 32. So I can just write as what? Y is equivalent to log 2, and I can write 32 as 2 to the power 5. Now we can use the approximation of what? Log m to the power n as n log m. So I can write this as y is equivalent to 5 log base 2 and the term is 2. Do you know that always if the base and term are same, then the value of it is always 1. So I can say the value of this became just 5. So the value of log 32 base 2 is just 5. If you understand all the things which I explained for log, then I think this is sufficient information to